Hi everyone, I wanted to do a quick video about what I'm giving you for the final exam. So I said I was going to give you some extra code. When I started building up all the various questions for the exam, I hit 3 different things. So I'm giving you code for 3 different parts in case you're wondering. So under provided W21, so winter 21 code, BIT2400, you should see 3 directories. The first directory is the linked list demo. That should just be purely linked list, an implementation of linked list. It'll use an iterator. You've actually seen this implementation of linked list before. I'm going to go and open it up in a second. We also have MVC shapes. These are just the 2 shapes that might come up on the exam, but not necessarily you building something new, or I'm not saying how it's going to come up. But we did look at model view controllers. We have looked at code. We looked at refactoring our code for in assignment 5B. So here is an animating rectangle from the lab. I can show you that. I think I show you an example of that in the lab. So it's this rectangle that just does this all the time. It has a timing. It deals with timing events. And then we have a circle 2400. Okay, so you can look at those that code because it will be related to what we're doing for the exam. Remember, I can't give you something huge in terms of code for you to do, but I can give you stuff that requires you to understand topics. So if it's using a linked list, or if it's extending a linked list, or if it's building something using a linked list, or let me think of another example, right? I could use something like, here is some code, and find the errors in the code for a revised version of this, or I could say, here, extend this class, or I could say, what would you expect for the output, that sort of thing. And finally, we have provided this code here. And this code here is, we have linked list data, fine. We have a linked list, we have a hash table. This is a variant on our normal hash table. Our normal hash table was just an array that we find where to put things in the array, in that table, quickly. We have some kind of hash function that just says, put it in position 5, and you just stuff your data in position 5. And the problem we hit was, if 2 items are supposed to go in position 5, we have what's called a collision. We have 2 things going in the same location. And for the assignment, we just said, oh, too bad, sucks to be us, and that was it. What we could do, and I actually gave that as an exam question, it was maybe a bit too hard a while ago, was what if we, instead of making just an array of items, we make an array of linked lists, and each of those linked lists have our items. So if I have a collision, item 17 and item 5 go in the same location, then I just put both items in the linked list. I still have this quick lookup, but I could have more than one item in this linked list. It is slightly slower, but it doesn't have the problem we had before with collisions. I have a demo of this in action. So let's have a look at some of these things. Here's the code in action for this. So this is my linked list iterator, and I have screaming kids, so that's going to be fun. This thing is going to insert a bunch. I have made a linked list. I make a bunch of linked list data. That linked list data is just, it is a object wrapping around an integer just to put, so I can put the data in. Actually, this is a structure wrapping around an integer. Well, I'm going to insert a bunch of data at the front, at the back. We've already done this in the lectures as well. In case you're wondering, this is not the first time you should have seen this. Then I'm going to have an iterator that walks down my linked list and outputs all the items in my linked list, just to show you that other than just using the print linked list function, so here's me printing off the linked list itself, just calling the one function, but I could use an iterator to get individual elements in my linked list by just getting the next, the next, the next, until there is no more next, essentially. So if I run this code, and I'm going to pause it before I get other things maybe, but here is what I need to move it to the right page. There you go. Here is my linked list that I've added all these items to. I use my iterator and I show that at position 0, I have 17, position 1, index, the next node in my linked list is I have keep value -2, 9, 21, and 0. And then I'm going to remove some items and delete them. Just I'm testing out how my linked list works. For all of these things, what I have is, this one doesn't show it. There's a good one. Most of my comments for things, how the function or how the class should work, is in the header file, because that's what you need to know how to use it. And I have things like potential practice problems, things that you could try if you want. They're not what's on the exam. They're just things you can try to practice using these data structures. Okay, so that is our linked list. I should have the other one. Nope, I do not have the other one open. I had the other one open and I must have shut it down. So let me have a quick look at this project. I'm sorry, I had everything opened up ready to go for you guys, and then did not afterwards. Okay. Boop-a-doo. I'll have to just hold on. I'm going to pause it for 2 seconds. I may be not pausing. Yeah, I'm not pausing yet. Okay, and I'm back for 2 seconds. Here is my code for the hash table. And my hash table, essentially, the reason I needed a separate linked list thing is because that's really hard to extend. So hopefully the camera seems to be a bit jittery right now. Hopefully it's not too bad. My linked list using in a hash table is templated classes. So they're only in the .h file. It means I can store whatever I want in there, or as long as it fits the template. So it's a bit more general than you might need, but we could do that. Okay, so I have some code just in case you want to see other examples of other things you could do. That is this extra code start section here. But really the thing for you to look at is here. Here is me making a bunch of linked list data items. I'm inserting all those into a hash table. How's a hash table built? It just is. And I can check to see if what you could do is make a whole bunch of different items, stick them in the hash table, and see what it outputs. When I run this thing, hopefully I can run it. Let's build it, just to make sure. All right. When I run this thing, what we should get, hopefully not a crash. There you go. Wow, my system is slow. Notice I have all the items in my hash table, but if I had more than one item, it would put a bunch of items in here. It would put like 0 and 29 and 273, whatever the case is. The things where multiple items are stored in the single position in the hash table. Okay, so that is hash table. This is one of those things that you can also practice with, play with, and make sure you know how to use it. So we have 3 different pieces of code that I want you to look at that will show up on the exam. Okay, with that being said, I'm going to stop now, and hopefully that clarified things a little bit. The point is you can take this and play with it and sort of expand it on your own, just to make sure you feel comfortable with it. Don't just read the code and go, yeah, I got it. Or glance it over and go, I don't know what it does, but I'm sure it's fine, right? You will not figure this out on the exam. I want to give it to you in advance just to make sure you have time to digest what the heck I'm trying to say here. Okay, thank you very much for listening, guys, and I will talk to you soon. Thanks.